Welcome to part 13 of the CipherVibe Cloud Security Capabilities series. This episode explains Cloud Cost and FinOps, why it matters, how the capability works, which mistakes weaken it, and how to build it in a measurable way. Cloud FinOps creates shared accountability for the variable cost and business value of cloud services. Security and cost are connected because architecture, retention, data movement, logging, resilience, and unused resources affect both financial and risk outcomes. The key idea is that a security capability is more than a product feature or a collection of alerts. It combines people, process, technology, decision rights, evidence, and continuous improvement. We will examine its architecture, operating workflow, failure modes, defensive controls, implementation roadmap, and useful metrics. Coverage is not the same as effectiveness. A dashboard can show thousands of checks while the capability still fails because evidence is stale, ownership is missing, or remediation is never verified. The business outcome should be explicit. Teams need to know which loss scenarios the capability reduces, which systems are in scope, and which remaining risks require a conscious decision. To understand Cloud Cost and FinOps, start with its architecture and vocabulary. The capability should create a traceable chain from source evidence to a security decision and then to an accountable action. First, allocation maps spend to owners, products, environments, customers, and business outcomes using accounts, tags, labels, and billing data. Second, unit economics translates raw cost into measures such as cost per transaction, customer, workload, model inference, or protected asset. Third, optimization includes right-sizing, scheduling, storage lifecycle, commitment management, architecture, and deletion of genuinely unused resources. Fourth, FinOps governance combines visibility, budgets, forecasts, anomaly detection, engineering action, and executive decision rights. These concepts need shared identity, timestamps, provenance, ownership, and access control. Every summarized risk should link back to its source evidence and disclose missing information. A sound architecture separates collection, normalization, analysis, policy, workflow, and presentation. Teams can then test freshness, identity resolution, policy results, owner routing, and closure independently. Design for degraded conditions. Providers impose rate limits, schemas change, credentials expire, and events arrive late. A professional capability reports uncertainty and health instead of presenting incomplete information as fact. Trust boundaries deserve equal attention. Identify where data crosses accounts, tenants, regions, vendors, privilege levels, and administrative domains, then apply authentication, authorization, validation, encryption, and audit controls at those boundaries. A useful operating model for Cloud Cost and FinOps follows a repeatable evidence lifecycle. First, ingest complete billing and usage data, establish allocation rules, and quantify unallocated spend. Second, create ownership views and forecasts that teams can reconcile with deployment and business activity. Third, detect anomalies using seasonality, change events, resource context, and accountable thresholds. Fourth, prioritize optimizations by savings, engineering effort, reliability, security, and contractual constraints. Fifth, verify realized savings and monitor whether cost, performance, resilience, or security regress afterward. The workflow does not end when a ticket closes or an API returns success. Security closure requires fresh evidence showing that the risky condition is gone and does not immediately recur. Ownership should be established before urgent findings arrive using service catalogs, business applications, on-call schedules, and escalation paths. Prioritization should explain the influence of exploitation, reachability, privilege, data, business criticality, compensating controls, and confidence. Repeated findings should drive changes to secure templates, defaults, libraries, identity patterns, and architecture standards. Define escalation points for missing owners, disputed priority, failed changes, and evidence that suggests active compromise. Those conditions should move into incident or risk governance rather than remaining indefinitely in a routine queue. The fastest way to evaluate cloud cost and FinOps is to study how the capability can fail. First, aggressive right-sizing can reduce resilience or leave too little capacity during incidents. Second, deleting apparently idle security logs, backups, keys, or recovery resources can create serious control failures. Third, savings estimates are overstated when commitments, data transfer, licensing, and engineering effort are ignored. Fourth, poor allocation turns FinOps into central blame instead of a collaborative engineering practice. Fifth, tag-only governance fails when resources are ephemeral, shared, inherited, or created outside approved templates. These failures share a pattern. A local measure looks successful while the full outcome is weak. A connector, scanner, or repair can report success while coverage, exploitability, or recurrence remains unresolved. Measure whether the program improves important coverage, shortens exposure time, removes attack paths, and prevents recurrence, not how many alerts it produces. Exceptions need a reason, owner, compensating controls, approval, and expiry. Automation should reflect confidence, reversibility, blast radius, and business impact. Test both through controlled failure exercises. Correlate weaknesses instead of reviewing them separately. A moderate configuration issue, broad identity grant, exposed service, and sensitive data store may combine into a severe path even when no individual alert looks critical. A dependable cloud cost and FinOps program uses defense in depth. No single scanner, policy, gateway, or agent should be expected to carry the entire outcome. First, use hierarchical allocation with account structure, tags, metadata, ownership systems, and shared cost rules. Second, protect mandatory security, resilience, retention, and regulatory requirements from unreviewed optimization. Third, combine budgets and anomaly alerts with deployment events and owner routing. Fourth, use architecture review for data transfer, storage, observability, managed services, and commitment decisions. Fifth, track realized rather than theoretical savings and include performance, reliability, and risk guardrails. Control design should include preventive, detective, responsive, and recovery layers. Together, they establish safe defaults, identify drift, govern containment, and restore service. Least privilege applies to connectors, agents, orchestration identities, data stores, and administrators. Scope, separate, monitor, rotate, and test their access. Every control needs an owner and test strategy. Validate it with representative assets, negative cases, simulated attacks, provider failures, and rollback exercises. Integrate controls with engineering through clear pull requests, owner routing, reusable fixes, documented standards, and fast feedback. Preserve an evidence trail from detection through decision, approval, change, and verification. That lineage supports investigations, audits, lessons learned, and fair performance measurement without forcing teams to reconstruct history from separate systems. A practical implementation roadmap for cloud cost and FinOps should build trust before scale. First, establish billing visibility, allocation, and owner accountability. Second, address obvious waste and high-confidence scheduling opportunities without weakening controls. Third, introduce unit economics, forecasting, and anomaly response into engineering workflows. Fourth, coordinate commitments and architectural optimization with product roadmaps. Fifth, integrate security findings so cost actions do not remove evidence, resilience, or protective capacity. The roadmap is incremental because a focused production scope lets teams validate evidence, ownership, workflow, and control safety before scaling. Useful measures include allocated spend rate, forecast accuracy, realized savings, cost anomaly response time, and unit cost by product. Give every metric a precise definition, data source, owner, and known limitation. Pair lagging indicators such as exposure age with leading indicators such as coverage, control health, exception expiry, and secure template adoption. Maturity means the organization can discover important risk, explain it, assign it, act safely, verify the result, and learn from recurrence. Review the roadmap quarterly. Changes in architecture, threat activity, regulation, business strategy, and provider services can alter both priorities and assumptions. Retire metrics and controls that no longer guide useful decisions. For more cybersecurity market intelligence, research, and educational briefings, visit CipherVibe.com. CipherVibe is operated by Cloudsectech LLC. This video is general education, not legal, compliance, financial, or incident response advice. Never access or test systems without explicit written authorization.